Okay, so we're on to our last passage. We know that passage 5 is always natural science. We know that natural sciences sometimes have a graph, so hopefully you double checked your passages before you started and you knew that this one does have a graph. It is a natural science, so if you're running out of time, this would be a great piece to eject cord. So again, because we know it's natural science, let's see, get my pen back. Sorry about that, guys. We know it's natural science. We know its job is to inform. If we read this little introduction here, we can see that this is titled Inventing Tougher Plastic with 50% Renewable Content. So we know we're going to be looking at plastic and trying to make plastic stronger. So let's go ahead and start diagnosing questions. I'm going to do this a little bit differently. I'm not going to eject cord it, but I will walk you through kind of like processing what these questions might look on an eject cord. So question number 42. Author mentions in order to. So notice how I'm not even reading the full question. I'm skipping around to try to find my keywords because I don't want to waste a lot of time. That in order to and asking about the author why he does something, that lets me know that it is a purpose function. It references the first paragraph, so I'm going to go back and bracket that first paragraph. Why do we mention these things? I need to stop and think about that as I read. Number 43, as used in line 12, pretty obvious word in context. Let's go to line 12 and we'll circle the word forms. So right here, we're going to circle that. Number 44, one function, and we reference a paragraph. So again, a very obvious purpose function question. We need to go to the third paragraph and bracket that. So 1, 2, 3. We'll make sure that those are the right line references, so 24 through 36. And that's what we're looking for. Okay, 45, the author suggests. Inference and suggestion question. Let's check for a COE follow-up first. It does have one. So I don't need to know what this is asking about. You can connect these a couple of different ways when they're on two different pages. I like to do this because it reminds me to look at the next page, and this reminds me to look up at the previous page. Some students like to do this. That becomes just like kind of one more line than I want to look at, and it also it takes away my room to take notes over here if I need to, which is why I prefer just kind of that one little arrow down and arrow up. But whatever works for you, do that as long as you're making sure that they're connected. So again, I don't need to know what this question is asking about. I'll find the answer somewhere within these lines of evidence. 47, information in the passage best supports which statement? Okay, so best supports and referencing in the passage, combining these terms, I can figure out that it is an inference question. So again, I'm going to see if there is a COE follow-up. There is, so I can loop these together. I don't need to know what 47 is asking about. 49, according to, ACC is always AC&C. This doesn't have a COE follow-up. It has a word in context, so we need to figure out what this one is asking about. According to the passage, his team used nitrile rubber. So according to the passage is just a question words. NASCAR, he may be important if he's not the scientist over the whole piece. Sometimes he is. So his team, we need to find that word or phrase that really sticks out. So something about nitrile rubber, and we want to know why it was used. So why use nitrile rubber? Make sure that you're working on translating these, even if it's just in your head, so you kind of know what's being asked. Because if all you do is NASCAR's team used nitrile rubber in his study because, you're not processing that information. So go ahead and translate it in your head. Why did they use nitrile rubber? Okay, we know that there is a word in context. Right after that, line 73, the word properties, which means that this answer is going to be somewhere between line 73 and line 24. Whenever there's this parenthetical, I like to go, if it's before the other question, I like to look at the beginning line. If this pair came after the question, I would look at the end line because I want to consider that entire gap when I'm considering my chronological order. So again, this answer is going to be somewhere between line 24 and line 73. So let's go ahead and circle properties in 73 before we move on though. Line 73. 1, 2, 3. Okay. the word properties. Let's move on. We have 2 questions left. I'm betting they're graph questions. Okay, according to the graph, yep. And once I have one graph question, they're all going to be graph questions. Even if it's a COE, it's a COE graph, so I don't need to know what that's asking. So we'll worry about that later. So if we go back, first paragraph, so this would have been kind of that tier 2, maybe a tier 3, depending on how long the paragraph was. Here we would have a tier 1. I'm just going to call this a 2 for argument's sake. Third paragraph, it's kind of a longer one, so again, maybe a tier 2 or 3. Then we have a COE pair. Oh my gosh. So we have, that would be a tier 1, that would be a tier 1, that would be a tier 1, that would be a tier 1. Tier 2, maybe a tier 3. It doesn't have a COE follow-up. It does have this gentleman's name, but if he's referenced throughout the passage, that might not be helpful. But I can probably spot the word nitrile because it's kind of a different word. So I would call this a tier 2 because I trust myself to find that word. If it's a tier 3 for you on test day, that's fine. Another tier 1 question. And then the graph, this doesn't look like it references the passage, so it would be a tier 1. This does not look like it references the passage, so it would also be a tier 1. So look at all those tier 1 questions that you could answer without reading the passage. The nice thing is even your higher tiers are only paragraphs long. This one we know where we can look for something, so this would be a great piece to eject cord if that's what you needed to do. So let's remind ourselves of our roadmap. We're going to stop and think of why the author mentions these objects in the first paragraph. We're going to stop at the word forms and try to come up with a different idea or concept behind that word. We're going to stop after the third paragraph and just kind of ask ourselves what role it's playing within the piece as a whole. We're going to look for nitrile rubber, and then we're going to stop at the word properties. So not too much to keep in mind. All right, so we know that this is going to be important. Why do we list a bunch of everyday objects? A car's bumper is usually made of a moldable thermoplastic polymer called ABS, shorthand for a bunch of words I probably don't need to know. Light, strong, and tough, it is also the stuff of ventilation pipes, protective headgear, kitchen appliances, Lego bricks, and many other consumer products. Useful as it is, one of its drawbacks is that it is made using chemicals derived from petroleum. So my focus here was on all these objects. What I'm noticing here is there's a variety of objects. So like bumpers and headgear seem protective in some capacity, but ventilation pipes and appliances are like home necessities. Lego bricks are fun toys. So it sounds like this plastic does a lot of things. So maybe that's the point, is to show us how versatile it is. I'm going to actually leave myself a note just in case. Versatile, maybe? Researchers at the Department of Energy's lab, so the Ornell lab, have made a better thermoplastic by replacing the styrene, the S word, with lignin. Okay, so now instead of ABS, it's like ABL, I guess. Lignin is a brittle, rigid polymer that, combined with cellulose, blank the woody cell walls of plants. Okay, so the lignin plus cellulose makes up a plant cell walls, so I'm going to say makes up. So plant cell walls are made of lignin and cellulose. So that's kind of the visual I'm going to keep. Even if this word made up or makes up or comprises, composes isn't there, I know that the walls are made of these two things. In doing so, this is back to the team, they have invented a solvent-free production process that interconnects equal parts of nanoscale or really tiny lignin dispersed in a synthetic rubber matrix to produce a meltable, moldable, ductile, I don't know what that word means, that's a ductile material that's at least 10 times tougher than the original ABS. The resulting thermoplastic, called ABL, because remember we just replaced the S word, stands for a bunch of words I don't need to know, is recyclable, so that's nice, as the ABL can be melted 3 times and still perform well. The results, published in the journal of this journal, may bring cleaner, cheaper raw materials to diverse manufacturers. All right, so now we have a purpose function. Why is this paragraph important? The technology can make use of the lignin-rich biomass byproduct stream from biorefineries and pulp and paper mills. So it's using a waste product. That's nice. With the price of natural gas and oil dropping, renewable fuels can't compete with fossil fuels. That's that petroleum. So biorefineries, like the paper mills and stuff, are exploring options for developing other economically viable products in addition to just their fuels. Among cellulose, hemicellulose, and lignin, the major structural constituents of plants, lignin is the most commercially underutilized. So it looks like there's 3 plant products, and maybe we use 2 of them more than lignin. Underutilized means we don't use it enough. The Ornell Lab study aimed to use the lignin, with an eye towards commercialization, a renewable thermoplastic with properties rivaling those of current petroleum-derived alternatives. So we're using this plant-based material to replace the petroleum-derived material to make a stronger, more renewable, better plastic. So that's the lab's purpose. So it kind of introduces like why this is necessary. The biorefineries are needing to be more marketable because petroleum fuel is dropping and therefore people are going to want to use it more. So the biorefineries need to make themselves more marketable. We can do that by using our byproducts to create something that the world needs anyway. So that seems good. Lignin is a very brittle natural polymer, so it needs to be toughened, explained study author Ammar Naskar. So that's that guy's name. So we're now learning about him. Leader of the Ornell's Carbon and Composites group. A major goal of this group is producing industrial polymers that are strong and tough enough to be deformed without fracturing. We need to chemically combine soft matter with lignin. That soft matrix would be ductile so that it can be malleable, that's like shapeable, I think of Play-Doh, or stretchable. Okay, so we need to be able to do both things. Very rigid lignin segments would offer resistance to deformation. I wonder if that's like the recycling process, and thus provide stiffness. All lignins are not equal in terms of heat stability. To determine what type would make the best thermoplastic feedstock, the scientists evaluated lignin from wheat straw, softwoods like pine, and hardwoods like oak. So we found plant material from 3 different plant families. They found that hardwood lignin is the most thermally stable, and some types of softwood lignins are also melt stable. Next, the researchers needed to couple the lignin with soft matter. Chemists typically accomplish this by synthesizing polymers in the presence of solvents. Because lignin and a synthetic rubber containing some word called nitrile rubber. Oh, that was one of our words. We need to look for nitrile rubber. Okay, so an answer might be here. Okay, so because lignin and nitrile rubber have chemical groups in which electrons are unequally distributed and therefore likely to interact, okay, so they have like electron composition that's similar and it makes them likely to interact, whatever that means. The team instead tried to couple the two in a melted phase without solvents. Okay, so the lignin plus the nitrile in a melted phase without solvents, because their electron makeup is similar, and so they're likely to interact even without solvents. Okay, there's something there. In a heated chamber with 2 rotors, the researchers needed, so that's like the malleability, a molten mix of equal parts powdered lignin and nitrile rubber. During mixing, lignin agglomerates broke into interpenetrating layers or sheets of 10 to 200 nanometers that dispersed well in and interacted with the rubber. So it sounds like it worked. Without the proper selection of a soft matrix and mixing conditions, lignin agglomerates are at least 10 times larger than those obtained with the Ornell process. The product that formed had blank of neither lignin nor rubber, but something in between. So it wasn't like lignin or rubber, it was like a hybrid. So it had like traits, characteristics, with a combination of lignin stiffness and nitrile rubber's elasticity. So perfect. That sounds like a great way to make plastic. All right, so we talked about forming being kind of like making up or composing. Properties are like traits or characteristics. We learned about all these different items because maybe we wanted to see the versatility of this material. And then here we learned kind of like why the lignin was coming into play. Okay, so purpose function. The author most likely mentions several commonplace objects in the first paragraph in order to. So we talked about versatility, and A says give a sense of the range of uses. So that's like versatility, that ABS, that rubber can be used. So possibly, I'm going to check it. indicate that the plentiful supply of ABS had led to its devaluation. We don't learn about supply, and the only time we learn about devaluation is in that third paragraph and not really in that way. So I'm going to say B is incorrect. Provide examples of potential alternatives to ABS. Well, it's not potential alternatives, it's current uses of. So C is incorrect. Suggest that environmental concerns will curtail reliance on ABS in manufacturing. We did talk about it being petroleum-based, but that paragraph wasn't about potential concerns or environmental factors, and we're not even being asked about the paragraph as a whole. We're being asked about the commonplace objects. So that's what makes D wrong. So A is our correct answer. All right, 43, as used in line 12 word forms. So we said makes up, composes, and look, composes is already offered to us. Let's disprove everything else though, just in case. We are not acquiring the cell wall. We are a component of the cell wall. We are not conceiving of the cell wall either as an idea or as like a reproductive conception. It is just a component of it. And again, it's not what is organizing it. It's not doing the job of telling what things where to go. It is just a piece within the plan. All right, number 44, function of the third paragraph. So this is where we learned kind of like why lignin came into play. We learned about biofuels being more expensive than petroleum fuels, fossil fuels. So let's see what they offer us. Describe the methods used by his team in its research. Okay, we don't see the methods. It's more of the why, not the how. So A is incorrect. Suggest a rationale for the research conducted by NASCAR's team. Maybe, because it tells us like why the lignin came into play. I don't have anything that I can get rid of on here, so I'm just going to hold on to it, and maybe I can find something better, maybe not. Describe the scientific phenomenon that NASCAR's team attempted to explain. No, it's more of an economic phenomenon or a supply-demand type of phenomenon. So C is incorrect. Discuss the practical benefits that have resulted from the work of his team. We don't really see the results of his team's work yet. We're seeing kind of like why they're choosing to move to this product. So I'm not seeing the benefits, and it's not a result. So I'm going to get rid of D. So even though B doesn't talk a whole lot about any of the key phrases, this rationale goes with our idea of like, why are we doing this? And so because this kind of tells us the why, B is the correct answer. All right, number 45 is an inference question. Now we can figure out what we're actually being asked about. So author suggests, that is just a question word. Decrease in cost of fossil fuels. Oh, we just read something about that in paragraph 3. So decrease in cost of fossil fuels has led to something. So because fossil fuels cost less, there is some kind of effect. Now, we know it was in that paragraph that we just read, but look, all these lines of evidence are too. Checking our parentheticals, there doesn't look like there's anything super helpful. B does reference products, and maybe it's products of fossil fuels, but we're just gonna have to read everything. 24 through 26, let's start there. All right, 24 through 26. The technology could make use of the lignin-rich biomass product stream from biorefineries and pulp and paper mills. Okay, so that is about the biorefineries, not about fossil fuels, so we'll get rid of that one. 26 through 29. So starting here and ending here. With the price of natural gas and oil dropping, renewable fuels can't compete with fossil fuels. Okay, so we have fossil fuels and we have prices dropping. So biorefineries are exploring options for developing other economically viable products. So that covers all of our bases, fossil fuels and prices dropping. So that could be a good option. So let's save that one. C, 30 through 32. So here and 31, 32 right here, sorry. Among cellulose, hemicellulose, and lignin, the major structural constituents of plants, lignin is the most commercially underutilized. Okay, so let's talk about plants and lignin, not fossil fuels, so we can get rid of C. Lines 32 through 36 for D. 32, all the way to the end. The Ornal study aimed to use it to produce with an eye, okay, the it here is lignin, with an eye towards commercialization, a renewable thermoplastic with properties rivaling those of current petroleum-derived alternatives. So this is about the lignin, even though it references petroleum-derived alternatives, it doesn't talk about a price drop, and that's a pretty vague discussion of the petroleum. So I'm going to say that that one is lignin-focused and not really reversible. Sometimes we can read something in the inverse and then turn it into an inference, but this is not talking about, it doesn't have that decrease in cost. So even though it references petroleum, it's not doing our job. So the answer is somewhere in B. So a decrease in cost has led to what? So let's reread that and see what the decrease in cost has led to. With the prices of natural gas dropping, renewable fuels can't compete with fossil fuels. So here's the result. Biorefineries are exploring options for developing other economically viable products. So biorefineries are trying to figure out ways to keep up since their prices aren't as low. They still need to be marketable. Has led to near exhaustion of fossil fuel reserves? No. Unsustainable energy consumption patterns. So we're not learning about energy consumption. We're learning about using alternative materials to make products. A repudiation of renewable energy initiatives. I don't know what repudiation means, but it's not about renewable energy. We do talk about the bioenergy, but it's more about like them trying to stay marketable. I'm guessing it's not this, but let's read D just in case. A drop in the demand for alternative fuel sources. It said, so the reason they're trying to remain marketable is because the renewable fuels can't compete with fossil fuels. So they can't keep up. That's kind of the whole point. So we can match that phrase, concept for concept, to D. They can't keep up, so we're seeing a drop in demand for alternative fuels. That's an inverted way of saying they can't keep up. All right, so let's look at number 47. Information in the passage best supports which statement about lignin? So the big thing that we're looking for is something about lignin, something that is true about lignin based on the passage. So let's see what we can find. Starting with lines 37 through 40. Okay. So lignin is a very brittle natural polymer, so it needs to be toughened, explained this guy. Okay, so lignin is naturally brittle. It needs to be toughened. So that is true, and it is about lignin, so let's hang on to it. Oh, wrong button. All right, so A is true. We'll hold on to that guy. Lines 42 through 43. Wait, 41, 42, and 43. We need to chemically combine soft matter with lignin. Well, that's something that we need to do to lignin, but it doesn't really give us any information about lignin. So even though it mentions the word lignin, it doesn't give us information about lignin other than something else needs to be added to it. So I don't feel as great about that one. Maybe I'll put a dot next to it because I don't want to completely get rid of it, but A feels better just because lignin's mentioned but not discussed. C, 45 through 46. All right, very rigid lignin segments would offer resistance to deformation and thus deformation, and thus provide stiffness. Okay, so this is something that it would do to a different process. So it's not about the lignin itself necessarily. So it does mention the word lignin, but we don't get a description of the lignin itself. So kind of just like B, we get the word, but we don't really get something that is true about lignin. So let's check D just to be safe. 47. All lignin are not equal in terms of heat stability. Okay, so again, this is how it is reacting with heat stability, but it doesn't tell us why they're not equal or anything about the lignin itself. So we can actually get rid of that one. So I think the common ground between B, C, and D is they all mention the word lignin, but none of them tell us anything about lignin. So A is our answer. Let's go back and remind ourselves what it says about lignin, 37 through 40. Lignin is brittle, and so it needs to be toughened. All right. It is too expensive. No. It is one of the few polymers that can be processed without the use of high heat. We don't see anything about heat, so A and B are incorrect. When combined with soft matter, it yields a polymer more stretchable than the original soft matter. Oh, here's that distractor. Because remember, we saw something about it needing to be mixed with soft matter. And so we could connect those two, but the problem is it never discusses in that phrase that it's more stretchable. So that is that distractor combination. I'm glad we didn't pick that line of evidence. D, it's in its unaltered state, it breaks too easily to be used in high performance. So breaks too easily is the same thing as brittle. That says brittle. It's beautiful. Okay, so D is the correct answer. This is one of the reasons that it's so important to do the COEs in reverse order, because if we had chosen C, we would have found a line of evidence that supports C, but it's incorrect because it's not really about the lignin itself. All right? So let's move on to number 49. Content question, and we're looking for that nitrile rubber. Why did the team use nitrile rubber in its study? So why do we use that? We actually already marked this because we found nitrile rubber just in the same place, this one place, and it said chemist, so his team, accomplished whatever this goal is because lignin is a synthetic, because lignin and a synthetic rubber, nitrile rubber, have chemical groups in which electrons are unequally distributed and therefore are likely to interact. They tried to couple the two, so they coupled the two because they were likely to interact because of their similar chemical groups. Okay, nitrile rubber is stiffer and more thermally stable than many other types of soft matter. Okay, we didn't discuss that here. It's about their similar makeups. The chemical composition of nitrile rubber suggests it would combine with lignin without the use of solvents. That's almost word for word. I'm going to assume this one is true, but let's prove C wrong. Sheets of nitrile rubber are only 10 to 200 nanometers thick and thus interpenetrate well with lignin in a melted phase. You know what? This information is from later, and I think it's a misunderstanding. Where did 10 through 200 come from? Okay, right here. During mixing, lignin broke into interpenetrating layers of 10 to 20 nanometers. So that's the lignin that did this, not the nitrile rubber. So that's what makes that wrong. That's a mishmash of concepts. Molecules of nitrile rubber and lignin have different numbers of electrons. Nope, it clearly said they had similar. That is an opposite of the relationship described. We'll get rid of it. It was B. Number 50, the word properties. We came up with traits or characteristics. The product that formed had characteristics of neither lignin nor rubber, but something in between. Okay, so it's not possessions. They don't have like purses that match. Compositions, maybe, but it's not the makeup. It's kind of like how, like characteristics. Maybe, but I don't love it. Qualities. Qualities feels much more like characteristics or traits, so I think it's probably this one. Objects kind of feels like possessions to me, something that the piece owns, and that's not the case here, so C is the answer. Now all we have to do is attack these graphs. So according to the graph, which source of lignin resulted in thermoplastic polymer with the greatest tensile strength? So source of lignin, greatest tensile strength. So let's take a look at the graph. Okay, look at this graph, guys. There are two y-axes. Look for that. So what that means is that tensile strength is being judged on this axis, whereas maximum stretch, the gray, is being judged on this axis. So let's remind ourselves what we're looking for. We're looking for a source of lignin, so that's which type of wood, that has the greatest tensile strength. Okay, so tensile strength is over here. So the highest black bar is this guy, softwood type 1. All right, so C is the correct answer. 52. According to the graph, the maximum stretch, so now we're on that other axis, before breaking, produced from softwood 2 is closest to what? So now we're looking for a number, so we need to make sure we're looking at the correct side of the graph. So maximum strength for softwood number 2. Let's take a look. Softwood number 2 is here. This looks to be about 500. So our answer is C again. All right, and you did it. That's all for October 2019. We'll have the March 2020 up soon.